Okay, good day, guys. Okay, for circular motions, so we're going to look at two type of circular motions, as I explained in the first lesson. Okay, the first one is a horizontal circular motion, and the second type will be vertical. Okay, for today, so I just going to explain about horizontal. Okay, one of the example is we already discussed under the uh, first or second questions from 8.16. Okay, where explain about, okay, when a car is moved around a roundabout, okay, what are the forces that acting, and how we can calculate the frictional force, okay, on for all the four wheels of the car, okay, while it's making the curve. Okay, and then how we can relate that to the centripetal force. Okay, for today, so we're going to look at on this video, so we're going to look at another example, okay, where it's involved horizontal circular motions. Okay, but we are using an example of chaeroplane. So you know what is chaeroplane, right? Okay, chaeroplane is normally in the amusement park, okay, or you go to Genting, so you can see this. Okay, so here, okay, let's say this is the pole. Okay, have a pole, and then, okay, this is the pole, and then there'll be a chain. Okay, this chain is, okay, attached to a chair. Okay, let's say you are sitting here in the chair. Okay, so while you are sitting, so you are making a circular motion. Okay, you are making a circular motion. Okay, or this whole thing is moving horizontally. Okay, yes. Okay, so even though it is swinging in a certain angle to the vertical, but you are moving in a horizontal circle. Okay, so when you're moving in a horizontal circle, you are not affected by gravity. Okay, it's the same like horizontal linear motions. For example, like when a car is accelerated from a certain speed to another speed. Okay, so we never use acceleration of 9.81, or we never use a gravity to calculate or to solve the problem. So it shows that, okay, so when the object is moving horizontally, so it is not affected by gravity. Okay, same goes for here. Okay, now, okay, so let's say you are moving in a horizontal circle, so you are not affected by gravity. Okay, first thing what we're going to do is we're going to look at, okay, what force is caused you to move in a circle. So it means, let's say if you are moving in this horizontally, so this is the circle, and this should be the center of the circle. Okay, and the distance from the center of the circle to the circumference, okay, this is we consider as the radius. Okay, so radius to the vertical is, since this is horizontal and this is vertical, so they always 90 degrees to each other. Okay, so that is the radius. Now, so since you are moving horizontally, so you are subject to the force that acting towards the center. So it means you are rotate, or you are swing around the center. Okay, or you are moving around the center. So it means you are like attached to the center, and then you are moving in this way. Okay, like a circle. Okay, now, okay, what is holding you towards the center? Okay, so from what we have learned from the lesson 1, so actually there is a force, okay, we call as a centripetal force, okay, which is holding you towards the center here. Okay, so now we're going to find, okay, the force that is holding you towards the center, and also, okay, what is the tension in the chain or the rope that attached to the chair. Okay, okay, now we look at, okay, this is the vertical, the post. Okay, first thing, so we label all the forces. Okay, so this is you with the chair. Okay, the first force on you is the weight. Okay, the weight. sorry. Okay, the weight, I write with mg. Okay, this mg can be, this mg should be the mass of the chair plus with the person here or with you. Okay, let's say you is here, times 9.81. This will be the weight. Okay, first one. Okay, now if there is a downward force, there also should be a upward force. Okay, so this downward force is balanced by the upward force. Okay, where you get this upward force from, this vertical force. Okay, this vertical force or the force that holding you, okay, is a component of the tension. The tension is the one holding you. Okay, so when we say weight is a vertical properties. So your weight is downward. So this force or the tension in vertical direction or the component of vertical component should be, you have to resolve this. So it should be T. Okay, so this is angle theta here. So you can see this angle also should be theta. So I mean it should be T cos theta. Because the vertical component is between the resultant and this, so the angle in between is given, so you get T cos theta. Okay guys, okay, so from here we can see that, okay, the upward force is balanced by the weight downward, so you can write T cos theta is equals to mg. Okay, so you get the first one. This is from vertical. Okay, okay, right? Okay, now okay, next one. Okay, next one we look at horizontal. Okay, so what makes you to move in a horizontal circle is a force that's subject to the center. That's we call as a centripetal force. Okay, this force is, you know, the force is exists there, but it's invisible. So why you can feel this. Okay, this force is also a component of the tension. Okay, this is the tension. So if you resolve here, so you get a horizontal component. Okay, horizontal component. So when you resolve, what you get here? So you should get, this is cos, mean this should be sine. Okay, so when you resolve here, you get T sine theta. Okay, so you get T sine theta. Okay, T sine theta, if you look at the arrow is moving up, so when you resolve, the T sine theta is moving in towards the into the circle. So that is we call as a centripetal force. Okay, which is equals to Fc. Fc means centripetal force. Okay, which will be equals to mv square over r second. Okay, so now, so this is horizontal. Okay, right? Okay, so now we look at both. Okay, if the question asks you to find what is the mass or when the angle and tension given, then you can use this only the vertical formula. Okay, or if they ask you to find what is the tension for the second one or the angle, then you still can use the second formula, or you still can use the first formula, because you just need to find the T and theta. Okay, from here, so we also can get another formula, okay, by solving equation 1 and 2. Okay, so what we do, okay, so we know that sine theta over cos theta is tangent theta, so it means we divide equation 2 divide by 1. Okay, so divide by 1, so T sine theta over T cos theta is equals to T sine theta mv square over r divided by T cos theta equals to mg. Okay, so from here T cancel, sine over cos is tangent theta is equals to m, can cancel or not? Yes, can cancel. Okay, so you get v square over rg. So you get a formula. So tangent theta is equals to v square over rg. Okay, So you also can calculate, okay, what is the speed you needed if the radius given and the angle given. Okay, and okay, for to solve question that related to this, okay, one more thing you need to know. Okay, vertical means it's not necessary cos, and horizontal not necessarily sine. So this also can be t sin theta, t cos theta, and this can be t sin theta. So it depends on the position of the angle. Okay, let's say if the angle given is here, angle given is here. So if I resolve, okay, when I close the angle, so horizontal should be cos theta, so t cos theta, and when you resolve against the angle, this should be t sin theta. So I mean the cos theta and sin theta, you don't memorize the formula, but you try to understand that this cos theta and sin theta is depends on the position of the angle. So the angle can be here or here. If here means it should be t cos theta should be the vertical. The angle is here, so the vertical should be t sin theta. Okay, clear? Okay. So now, okay, using this, so you can solve many problems that involving charoplane, and also we can say as yeah, it's related to charoplane. Okay. Okay, so till see you in the next video. Okay, so we end here. Thank you.